Welcome to the 2-hour process safety management of highly hazardous and explosive chemicals, simple keys to compliance. Over the next 2 hours, we will be covering 29 CFR 1910-119. The objectives will be to define what is PSM, who is covered by the standard, list the elements of the PSM standard, and locate additional resources. What is process safety management, or PSM? PSM is a standard that emphasizes the management of hazards associated with highly hazardous and explosive chemicals and establishes a comprehensive management program that integrates technologies, procedures, and management practices. Why did OSHA develop PSM? OSHA developed PSM because of past disasters, current disasters, and an overall perceived weakness in PSM programs. After you've read the PSM standard, it seems fairly simple from actually reading the CFR. However, the actual doing of this standard is much more complicated. We are now going to watch a brief video that shows previous disasters prior to the PSM standard being implemented. And this video will illustrate why PSM is so important.
I didn't even know that there was a Union Carbide factory, or that someone that makes this kind of gas existed. My nephew got up and started coughing very badly. He said, "Aunt, I think someone has burned a chili pepper or left a bonfire burning." We had a neighbor called Thakur. His son came running. He had a room near the Union Carbide factory. He said, "You'll have to leave this place within 2 minutes or else nobody will survive." When I opened my eyes, I just saw bodies all over.
(911) emergency.
I need every unit, 5 units to sugar fighting now. It's just blood. It's just blood. I need all 5 units to the sugar refinery now.
Breaking news tonight, a developing story at this hour, 7:30 this evening. The worst of all possible fears in a community, an explosion at the sugar refinery.
A rescue operation at a sugar refinery in Georgia is now a recovery operation. Authorities say an explosion rocked the Imperial Sugar Refinery, setting it on fire and injuring dozens. Firefighters found 3 bodies in tunnels beneath a building. 3 others are still missing. More than 30 people went to hospitals, some airlifted to a burn center in Augusta, Georgia.
On February 7th of this year, a huge explosion ripped through the Imperial Sugar Refinery in Port Wentworth, Georgia. 8 workers died instantly and 5 more have died in the months since the explosion from the horrific burns that they suffered. More than 60 workers were injured, some so seriously that they will never fully recover. This was a terrible disaster, one of our nation's worst workplace tragedies of the past decade.
This is the BP plant in Texas City, where a series of explosions hit that plant probably about 20 minutes ago now. The plant does produce a number of petroleum products and various fuels. We do not know exactly what it is that they were producing this afternoon. We do not know exactly what it is that is burning right now. We do know that about 1,800 people work at that plant. We have reports that there are injuries. We do not know how severe they may be, nor do we have any reports of fatalities. A number of people told us that they quite literally heard the ground shake and windows shattered as far as 7 miles away.
For me and many others, tomorrow will be a solemn day in Texas City, as it marks the second anniversary of a horrible blast that ripped apart my life and the lives of so many others. The explosion at BP's oil refinery murdered 15 people, including my parents, James and Linda Rowe. The true tragedy is that it was needless and completely avoidable. At approximately 1:20 p.m. that day, BP initiated a dangerous procedure at the refinery using outdated and faulty equipment that sent the equivalent of a tanker truck full of gasoline into the air. Dozens of workers were in trailers as close as 100 feet away and were not warned of the imminent danger when idling trucks ignited the devastating chain reaction explosion. It is of little comfort to us, but we hope that through this legislation to ensure more stringent worker health and safety standards, that their deaths won't be in vain.
This is not about a program, but is about people and how to protect them. We also included a combustible dust as part of this video. While combustible dust is not directly covered in the PSM standard, the hazards are similar. OSHA has discussed including combustible dust into a very similar program as PSM, and we want to keep this in mind. It's often common that a facility that's covered under combustible dust will also be covered under PSM. To continue on, OSHA developed the Process Safety Management Standard to prevent additional events like Bhopal, Pasadena, Texas, Cincinnati, Ohio, and Sterling, Louisiana. Many lives were lost and many people were injured during these disastrous events. In 1991, OSHA and EPA respectively released standards, the PSM and the RMP standards that apply to companies and communities surrounding them. The goal of the standards were for them to be mirror images of each other. However, they came out somewhat differently, which we will highlight later on in this 2-hour training session. In addition, process safety management is a standard intended to prevent the release of toxic, reactive, flammable, and explosive chemicals. Many industrial facilities must comply with OSHA's Process Safety Management Standard, as well as the Clean Air Act 112R EPA Risk Management Plan, or RMP. There are similarities to these standards, there's also differences. Process safety management is like the hazard communication standard. It's the employee's right to know. It protects the workforce, the contractors, visitors, up to a facility, and basically protects the entire workplace. Under this standard, there's 137 listed chemicals. Risk management plan is more like SARA Title III. It's the community's right to know. It protects the community, the general public around the facility, and protects adjacent facilities such as schools and hospitals. There are 77 named chemicals under this standard. Depending on what state you're in, there may be differences of whether you're covered under both standards, one or the other, or potentially both. For example, if you're in a federal state like the state of Georgia, and you are a municipality, you might be covered under Risk Management Plan, but because it's a federal state, you would not be covered under Process Safety Management. If you were in a state plan state, however, like the state of South Carolina, and you are a municipality, you could be covered both under PSM and RMP. Also, one of the differences is because of the different lists of chemicals, it's possible that your company has a chemical that's listed under PSM but not RMP, or vice versa. This adds to the challenge of being in compliance with both of these two standards for PSM and RMP. The Process Safety Management Standard was promulgated in 1991. Is it working? The answer is yes. Incidents are trending downward for fatalities and catastrophes, but we are still having events like BP Texas City. In 2005 of March, 15 workers were killed and 170 were injured during a major disaster at BP Texas City. There was major property damage, and since then, OSHA has fined the company $50.6 million in fines. Let's now take a look at the elements of the PSM standard. This is a performance-oriented standard. The OSHA Compliance Directive gives a nice example that demonstrates the interrelationship among all these elements listed on this slide. During a routine inspection of equipment covered under mechanical integrity, the maintenance worker discovers a valve that no longer meets the applicable code and must be changed. Because the type of valve is no longer made, a different type of valve must be selected and installed, covered under management of change. The type of valve selected may mandate different steps for the operators, covered under operating procedures, who will require training and verification in the new procedures, covered under training. The rationale for selecting the type of valve must be made available for review by employees and their representatives, covered under employee participation. When the new valve is installed by the supplier, covered under contractors, it will involve shutting down part of the process, covered under pre-startup safety review, as well as brazing some of the lines, covered under hot work permit. The employer must review the response plan, covered under emergency planning, to ensure that procedures are adequate for the installation hazards. Although management of change provisions cover interim changes, after the new valve is in place, the process safety information will have to be updated before process hazard analysis is updated or revalidated to account for the potential hazards associated with the new chemical. Also, inspection and maintenance procedures and training will need to be updated, covered under mechanical integrity. In summary, 11 PS elements can be affected by changing one valve. A reviewer, inspector, auditor, compliance officer would check a representative number of these 11 elements to confirm that the required follow-up activities have been implemented for the new valve. Let's now explore some of the elements in more detail. First is application. Facilities that use chemicals listed in Appendix A are covered. This list includes toxic and reactive highly hazardous chemicals which present a potential for a catastrophic event at or above the threshold quantity, or TQ. Examples of this include anhydrous ammonia, often used in food processing. The TQ is 10,000 pounds. Another example is chlorine. Chlorine is often used in water treatment. A 1-ton cylinder is around 2,000 pounds of chlorine. The threshold quantity, however, is only 1,500 pounds. So if your facility has 1 cylinder of chlorine, you're probably covered under PSM. Another way for a facility to be covered under PSM, if they are not using a chemical listed in Appendix A, is if they have a process which involves a flammable liquid or gas as defined in 1910-1200C, on site in one location in a quantity of greater than 10,000 pounds, in a single system, in a process on any given day. What does on-site in one location mean? OSHA in 2007 interprets on-site in one location to mean that the threshold quantity of a highly hazardous chemical, HHC, exists within an area under the control of an employer or group of affiliated employers. It also applies to any group of vessels that are interconnected or in separate vessels that are close enough in proximity that the HHC could be involved in a potentially catastrophic release. We also have to consider the effect of the MIR decision. OSHA states that they would not cite employers for violations of 1910-119 where stored flammable liquids in atmospheric tanks were connected to a process. unless the process outside of the amount in storage contained more than 10,000 pounds of the substance. Common industries that use chemicals covered under PSM include industrial organics and inorganics, paints, pharmaceuticals, adhesives, sealants and fibers, petrochemical facilities, paper mills, and food processing with anhydrous ammonia over the threshold quantity. An example in the pharmaceutical industry is a time-release tablet. They use isopropyl alcohol to create the layers in the tablet. Often, many of these companies use these chemicals but aren't aware that they're covered under PSM. In the next section, we're going to cover exclusions. An employer is exempt from the PSM standard when a threshold quantity of flammable liquids is stored in an atmospheric tank or transferred without the benefit of chilling or refrigeration. An example would be a tank farm. Hydrocarbon fuels are also not covered under PSM if they're used solely for comfort reasons. However, if they're also included in the production process, this would trigger the PSM program. Additional exclusions include retail facilities, oil or gas well drilling or service operations, or normally unoccupied remote facilities. Would deep horizon be covered under PSM? The answer is no, because it was strictly exploration. Also, other exclusions include normally unoccupied remote facilities. Employee participation is a critical element in PSM. Now that you have determined that you must comply with the PSM standard, you will need to form a team. Your team may include process engineers, operators, safety, maintenance, management, and consultants. Remember, you can't do it alone. This is a team activity. Now that you have your team in place, you will need to form a plan that lays out responsibilities, duties, reporting, document control, progress reports, and tracking changes. Now that you have formed your plan, you can begin the process of developing and implementing the PSM program. Under the hazards of the process element, you will do a hazard determination, which will include assessing the chemicals in your process chemistry, the quantity of the chemicals in pounds, and compare them to the Appendix A list of threshold quantities. For the toxicity information element, you will need to obtain toxicity information for the chemical or chemicals used in the covered process. This will often include material safety data sheets or MSDSs. You may also use other reference materials like the NIOSH Pocket Guide or the ACGIH TLVs. Under the technology of the process, we will look at process technology and process equipment. The requirements of the standard for process technology include block flow diagram or process flow diagram, process chemistry, maximum intended inventory, upper and lower limits, and consequences of deviations. The requirements of the process equipment include materials of construction, process and instrumentation drawings, P&IDs, electrical classification, release system design, ventilation system design, design codes, material and energy balances, and safety systems. Under the equipment and process element, you will need to identify each piece of equipment in the covered process by the P&IDs and block flow diagrams and number them. Each facility typically has their own unique identifying numbering process. Remember, you must follow form. You will need to be able to track each number throughout the entire PSM program. The mechanical integrity element of the standard requires mechanical integrity certificates for each element of the process and must be marked with a numbering system that follows form. Storage or retention of these documents is critical. Keeping them in a digital and hard copy format would be a good idea. In the event of a fire or a natural disaster, it may be very difficult to recreate these documents. The process hazard analysis, or PHA elements, are arguably the most difficult part of performing the PSM standard. The PHA process is dynamic and subject to revisions whenever changes are made. It must be performed by your PSM team and takes a significant amount of time and effort. A PHA process must be performed on each element of the covered process. A PHA is developed from the block flow diagram to P&ID to every component part. It is necessary to determine what might happen if an element of the covered process fails. There are many more elements covered under the PSM standard. They include inspection and testing, quality assurance, management of change, operating procedures, safe work practices, training, contractor management, emergency planning and response, incident investigation, compliance audits, and trade secrets. For management of change, a process must be thoroughly evaluated to fully assess their impact on employee safety and health and to determine needed changes to operating procedures. To this end, the standard contains a section on procedures for managing changes to the processes. Written procedures to manage changes, except for the replacement in kind, to process chemicals, technology, equipment, and procedures, and change to facilities that affect a covered process must be established and implemented. These written procedures must ensure that the following considerations are addressed prior to any change. First, the technical basis for the proposed change. Second, impact of the change on employee safety and health. Third, modifications to operating procedures. Fourth, necessary time period for the change. And fifth, authorization requirements for the proposed change. Employees who operate a process and maintenance contract employees whose job tasks will be affected by a change in the process must be informed of and trained in the change prior to startup of the process or startup of the affected part of the process. If a change covered by these procedures results in a change in the required safety information systems, such information must also be updated accordingly. If a change covered by these procedures changes the required operating procedures or practices, they must also be updated. For operating procedures, the employer must develop and implement written operating procedures consistent with the process safety information that provide clear instructions for safely conducting activities involved in each covered process. OSHA believes that tasks and procedures related to the covered process must be appropriate, clear, consistent, and most importantly, well communicated to employees. The procedures must address at least the following elements: steps for operating phase, operating limits, and safety and health considerations. For the steps for each operating phase, this includes initial startup, normal operations, temporary shutdowns, emergency operations, normal shutdown, and startup following a turnaround or after an emergency shutdown. Under operating limits, this includes consequences of deviation and steps required to correct or avoid deviation. Under safety and health considerations, this includes properties of and hazards presented by the chemicals used in the process, precautions necessary to prevent exposure, including engineering controls, administrative controls, and personal protective equipment. Control measures must be taken if physical contact or airborne exposure occurs. Quality control for raw materials and control of hazardous chemical inventory levels and any special or unique hazards must also be considered. In addition, safety systems, including interlocks, detection, or suppression systems, and their functions must also be considered. To ensure that a ready and up-to-date reference is available and to form a foundation for needed employee training, operation procedures must be readily accessible to employees who work in or maintain a process. The operating procedures must be reviewed as often as necessary to ensure that they reflect current operating practices, including changes in process chemicals, technology and equipment, and facilities. To guard against outdated or inaccurate operating procedures, the employer must certify annually that these operating procedures are current and accurate. For safe work practices, the employer must develop and implement safe work practices to provide for the control of hazards during work activities such as lockout-tagout, confined space entry, opening process, equipment or piping, and control over entrance into a facility by maintenance, contractor, laboratory, or other support personnel. These safe work practices must apply to both employees and to their contractor employees. For training and initial training, implementation of an effective training program is one of the most important steps that an employer can take to enhance employee safety. Accordingly, PSM requires that each employee presently involved in operating a process or in a newly assigned process must be trained in an overview of the process and its operating procedures. The training must include emphasis on specific safety and health hazards of the process, emergency operations including shutdown, and other safe work practices that apply to the employee's job tasks. For refresher training must be provided at least every 3 years or more often if necessary to each employee involved in operating a process to ensure that the employee understands and adheres to the current operating procedures of the process. The employer, in consultation with the employees involved in the operating process, must determine the appropriate frequency of refresher training. For training documentation, the employer must determine whether each employee operating a process has received and understood the training required by PSM. A record must be kept containing the identity of the employee, the date of training, and how the employer verified that the employee understood the training. For contractors, many categories of contract labor may be present at a job site. Such workers may actually operate the facility or do only a particular aspect of a job because they have specialized knowledge or skill. Others work only for short periods when there is a need for increased staff quickly, such as turnaround operations. PSM includes special provisions for contractors and their employees to emphasize the importance of everyone taking care that they do nothing to endanger those who are working nearby who may work for another employer. PSM therefore applies to contractors performing maintenance or repair, turnaround, major renovation, or specialty work on or adjacent to a covered process. It does not apply, however, to contractors providing incidental services that do not influence process safety, such as janitorial, food and drink, laundry, delivery, or other supply services. For the employer responsibilities, when selecting a contractor, the employer must obtain and evaluate information regarding the contractor's performance and safety programs. The employer also must inform contractors of the known potential fire, explosion, or toxic release hazards related to the contractor's works and the process. Explain to contractors the applicable provisions of the Emergency Action Plan. Develop and implement safe work practices to control the presence, entrance, and exit of contractors and contract employees in covered process areas. Evaluate periodically the performance of contractors in fulfilling their obligations, and maintain a contractor-employee injury and illness log related to the contractor's work in the process areas. Contractors must ensure that contract employees are trained in work practices necessary to perform their jobs safely. They are to ensure that contract employees are instructed in the known potential fire, explosion, or toxic release hazards related to their job in the process and in the applicable provisions of the Emergency Action Plan. They must document that each contract employee has received and understood the training required by the standard by preparing a record that contains the identity of each contract employee, the date of training, and the means used to verify that the employee understood the training. They must ensure that each contract employee follows the safety rules of the facility, including the required safe work practices required in the operating procedures section of the standard. And they must advise the employer of any unique hazards presented by the contractor's employer's work. For emergency planning and response, if despite best planning an incident occurs, it is essential that emergency pre-planning and training make employees aware of and able to execute proper actions. For this reason, an emergency action plan for the entire plant must be developed and implemented in accordance with the provisions of the OSHA rules. In addition, the emergency action plan must include procedures for handling small releases of hazardous chemicals. Employers covered by PSM may also be subject to OSHA's hazardous waste and emergency response regulations. For incident investigation, a crucial part of the process safety management program is a thorough investigation of incidents to identify the chain of events and causes so that corrective measures can be developed and implemented. Accordingly, PSM requires the investigation of each incident that resulted in or could have reasonably resulted in a catastrophic release of a highly hazardous chemical in the workplace. Such an incident investigation must be initiated as promptly as possible, but no later than 48 hours following the incident. The investigation must be by a team consisting of at least one person knowledgeable in the process involved, including a contract employee if the incident involved a work of the contractor, and other persons with appropriate knowledge and experience to investigate and analyze the incident thoroughly. An investigation report must be prepared including at least date of incident, date investigation began, description of the incident, factors that contributed to the incident, and recommendations resulting from the investigation. A system must be established to promptly address and resolve incident report findings and recommendations. Resolutions and corrective actions must be documented and the report reviewed by all affected personnel whose job tasks are relevant to the incident findings. This could include contract employees. The employer must keep these incident investigation reports for 5 years. For compliance audits, to be certain process safety management is effective, employers must certify that they have evaluated compliance with the provisions of PSM at least every 3 years. This will verify the procedures and practices developed under the standard are adequate and are being followed. The compliance audit must be conducted by at least one person knowledgeable in the process, and a report of the findings of the audit must be developed and documented, noting deficiencies that have been corrected. The 2 most recent compliance audits must be kept on file. For trade secrets, employers must make available all information necessary to comply with PSM to those persons responsible for compiling the process safety information, those developing the process hazard analysis, those responsible for developing the operating procedures, those performing incident investigations, emergency planning and response, compliance audits, without regard to the possible trade secret status of such information. Nothing in PSM, however, precludes the employer from requiring those persons to enter into confidentiality agreements not to disclose the information. Now let's take a look at a case study. The BP Texas City refinery is covered by PSM. It is the 3rd largest petroleum refinery in the United States, with a refining capacity of over 475,000 barrels of crude per day. It is located on a 1,200-acre facility in Texas City, Texas, which is southeast of Houston in Galveston County. They have 1,200 permanent BP employees and hundreds of additional contractors at the facility. We are now going to view an excerpt from the Chemical Safety Board Anatomy of a Disaster BP Texas City video, which recreates the events from the March 2005 explosion.
At 1:20 p.m. on March 23, 2005, a massive explosion and fire erupted at the BP refinery in Texas City, Texas. The explosion killed 15 workers and injured 180 others, many of them seriously. The blast occurred at the isomerization or ISOM unit, which produces materials to boost the octane rating of gasoline. The explosion shattered windows in homes and businesses up to 3/4 of a mile away from the 1,200-acre refinery. As thick black smoke billowed from the plant, authorities instructed some 43,000 Texas City residents to stay indoors. The accident cost BP billions of dollars in victims' compensation, property damage, and lost production.
This investigation was the largest and most comprehensive investigation in the history of the Chemical Safety Board.
CSB Supervisory Investigator Don Holmstrom led a 2-year investigation to determine the root causes of the accident.
We interviewed over 370 witnesses. We looked at thousands of documents, literally millions of pages of documents, and we examined the plant, inspected over 40 pieces of instrumentation and equipment.
The investigation team examined a wide range of safety systems, practices, and standards, and looked at human factors such as fatigue and communication between operators. The board's report was released at a public meeting in Texas City on March 20, 2007. Then CSB Chairman Carolyn Merritt presided.
Many of you here tonight had family members or co-workers who were victims of this explosion. To all of you, I express my deepest condolences and sincere wishes that society never allows another accident like this to occur.
The tragedy at BP was the worst industrial accident in the United States in nearly 15 years. The CSB concluded that it was the result of organizational and safety deficiencies at all levels of the company. We found that BP management had, for many years, overlooked warning signs of a possible catastrophic accident.
There's an old saying that if you think safety is expensive, try an accident. Accidents cost a lot of money, and they're not only in damage to plant and in claims for injury, but also in the loss of the company's reputation.
The reason why the Texas City accident has such an impact is because when people look at it, they can see that they are all in the same boat, that the problems which led to that accident are likely to be present at other sites around the world.
My fear is that some of the other refineries within the United States will feel that couldn't happen to me. And the ones that feel that that couldn't happen at their site is the ones that are set up to have it happen there.
The following CSB computer animation depicts the sequence of events over an 11-hour period leading to the explosion at the BP Texas City refinery on March 23, 2005. Several units at the Texas City refinery had been shut down for lengthy maintenance projects, which required nearly 1,000 contractors to be on site along with BP employees. BP had positioned a number of portable trailers close to process units for the use of contractors and other maintenance workers. Over a period of months, BP had located 10 trailers for workers servicing the ultra-cracker unit, including a double-wide wood-frame trailer that contained 11 offices and was regularly used for meetings. Though these trailers were located near the isomerization unit, the occupants were not warned the ISOM unit was about to start up, a potentially hazardous operation. At 2:15 a.m. on March 23rd, overnight operators began introducing flammable liquid hydrocarbons, known as raffinate, into a 170-foot tall raffinate splitter tower used to distill and separate gasoline components. Near the base of the tower, there was a single instrument that measured how much liquid was inside. It transmitted this information to a central control room located away from the ISOM unit. But this level indicator was not designed to measure liquid above the 9-foot mark. During normal operation, the tower was only supposed to contain about 6.5 feet of liquid. But during startups, operators routinely deviated from written procedures and filled the tower above the 9-foot mark, concerned that if the liquid level fluctuated too low, it would cause costly damage to the furnace. At 3:09 a.m., as the liquid neared the 8-foot mark, a high-level alarm activated and sounded in the control room. But a second high-level alarm, slightly further up the tower, failed to go off. By 3:30 a.m., the level indicator showed that liquid had filled the bottom 9 feet of the tower, and the feed was stopped. The CSB later estimated that the liquid was, in fact, at a height of 13 feet. But operators could not know the actual level because the indicator only measured up to 9 feet. The lead operator had been overseeing the startup from a satellite control room within the ISOM unit. At 5 a.m., he briefly updated the night board operator in the central control room about the startup activities. The lead operator then left the refinery early, an hour before the end of the shift. A new board operator arrived in the control room around 6 a.m. to start his 30th day in a row working a 12-hour shift. He spoke briefly with the departing night shift operator and then read the logbook to prepare for the startup. But the logbook did not clearly indicate how much liquid was already in the tower and equipment, and it left no instructions on routing of the liquid feed and products when the startup resumed. Instead, the control board operator only found a one-line logbook entry that said, ISOM brought in some RAF to unit to pack RAF with. At 7:15 a.m., the day shift supervisor arrived. Because he was more than an hour late, he received no formal briefing from personnel on the night shift about conditions in the ISOM unit. At 9:51 a.m., operators resumed the startup. They began recirculating the liquid feed and adding more liquid to the already overfilled tower. As new feed was added, startup procedures called for regulating the liquid level in the tower using the automatic level control valve. But the board operator and others had received conflicting instructions on routing the product. As a result, this critical valve was left closed for several hours, blocking the flow of liquid from the tower. A few minutes later, operators lit burners on the furnace to begin heating up the feed, part of the normal startup process. While the startup was underway, the day supervisor left the refinery on short notice just before 11 a.m. to attend to a family medical emergency. Contrary to BP's own procedures, no experienced supervisor was assigned to replace him. This left a single control board operator, now without a qualified supervisor, to run 3 refinery units, including the ISOM unit, which needed close attention. The refinery had eliminated a second board operator position following corporate budget cuts in 1999 after BP acquired Amoco. As the startup continued, the tower steadily filled with liquid, reaching a height of 98 feet shortly before noon, more than 15 times the normal level. But the improperly calibrated level indicator told operators in the control room that the liquid was at 8.4 feet and gradually falling. Furthermore, the control panel was not configured to clearly warn operators of the growing danger. It did not display flows into and out of the tower on the same screen, nor did it calculate the total liquid in the tower. Meanwhile, the maintenance contractors, who were not involved in the operation of the ISOM unit, left their work trailers to attend a company lunch, celebrating a month without a lost time injury. At 12:41 p.m., an alarm activated as the rising liquid compressed the gases remaining in the top of the tower. Unable to understand the source of the high pressure, operators opened a manual chain valve to vent gases to the unit's emergency relief system, a 1950s-era blowdown drum that vented vapor directly into the atmosphere. Operators also turned off 2 burners in the furnace to lower the temperature inside the tower, believing this would reduce the pressure. Nobody knew the tower was dangerously full. The operators did become concerned about the lack of flow out of the tower and began opening the valve to send liquid from the bottom of the tower to storage tanks. But this liquid was very hot. As it flowed through the heat exchanger, it suddenly raised the temperature of the liquid entering high up the tower by 141 degrees Fahrenheit. It was now about 1 p.m. Contract workers, unaware of the startup and the looming danger, returned from lunch and began a meeting in the double-wide trailer in the corner room closest to the blowdown drum. Over the next few minutes, the hot feed entering the tower caused the liquid inside to start to boil and swell. Liquid filled the tower completely and began spilling into the overhead vapor line, exerting great pressure on the emergency relief valves 150 feet below. At 1:14 p.m., the 3 emergency valves opened, sending nearly 52,000 gallons of flammable liquid to the blowdown drum at the other end of the ISOM unit. Liquid rose inside the blowdown drum and overflowed into a process sewer, setting off alarms in the control room. But the high-level alarm on the blowdown drum failed to go off. None of the operators knew of the catastrophe unfolding in the ISOM unit. As flammable hydrocarbons overfilled the blowdown drum, operators nearby saw a geyser of liquid and vapor erupt from the top of the stack. The equivalent of nearly a tanker truck full of hot gasoline fell to the ground and began forming a huge flammable vapor cloud. This scene, based on CSB computer modeling, shows how the vapor cloud expanded in just 90 seconds, engulfing the unit and the nearby trailers full of workers. About 25 feet from the base of the blowdown drum, 2 workers were parked in a pickup truck with the engine idling. As flammable vapor entered the air intake, the diesel engine began to race. The 2 workers fled, unable to shut off the engine. Moments later, witnesses saw the truck backfire and ignite the vapor cloud. Powerful explosions swept through the area. Computer modeling shows how the blast pressure wave accelerated through the ISOM unit, causing heavy destruction and igniting fires throughout the area. The workers inside the trailers were right in the path of the explosions. The fires continued to burn for hours. 12 of the 20 occupants of the double-wide trailer were killed, along with 3 workers in a trailer nearby. Dozens of others suffered serious burns, fractures, and other traumatic injuries. The wood and metal frame trailers were blown apart by the blasts. Firefighters struggled to rescue the injured and recover the victims. 50 large chemical storage tanks were damaged, and the ISOM unit remained shut down for more than 2 years.
During the early stages of our investigation, our team had noted there were multiple safety system deficiencies at the Texas City plant. We also found there was a history of fatalities at the plant.
Prior to the March 2005 accident, 23 people died in accidents over a 30-year period at the Texas City refinery, beginning when it was owned by Amoco and continuing after BP acquired the refinery in 1999.
The CSB wanted to know what the connection was between this history of fatal incidents and the organizational and cultural factors.
BP Corporation's lack of focus on preventing major accidents allowed budget cuts to be made without assessing the impact on process safety.
The CSB found that cost-cutting, production pressures, and failure to invest significantly impacted the process safety performance at the Texas City refinery and left the refinery vulnerable to catastrophe.
After the merger with Amoco, BP ordered a 25% reduction in fixed costs at all its refineries.
This impacted important process safety systems such as staffing, training, and mechanical integrity.
The effects of the budget cuts became apparent in a number of internal BP documents made public following the accident. In one, the refinery manager was quoted as having observed in 2002 that the infrastructure at Texas City was in complete decline. He ordered a study of the refinery's safety and mechanical integrity, a study which was shown to BP executives in London. That study warned of serious concerns about the potential for a major site incident following more than 80 hydrocarbon releases in the previous 2 years. The study also concluded that its own findings were urgent and far-reaching. A follow-up BP study in 2002 found the refinery's integrity and reliability issues were clearly linked to the reduction in maintenance spend over the last decade. In 2003, a maintenance assessment stated that cost-cutting measures have intervened with the group's work to get things right. Usually, reliability improvements are cut. And later that year, a company audit found the current condition of the infrastructure and assets is poor at Texas City, and that maintenance spending was limited by a checkbook mentality. Only the money on hand would be spent, rather than increasing the budget. In March 2004, BP auditors in London concluded that 35 business units around the world, including the Texas City refinery, suffered from a host of common safety problems, including widespread tolerance of non-compliance with basic HSE or health, safety, and environmental rules, poor implementation of safety management systems, and lack of leadership competence and understanding.
There were a number of reports that were coming up to as high as the board level that indicated serious problems throughout the BP system.
During 2004, the Texas City refinery had 3 major accidents. In addition to this process unit fire that caused $30 million in damage, 2 other accidents in 2004 resulted in 3 fatalities. Yet this same year, the refinery had its lowest ever recordable injury rate, a statistic that does not include fatalities. The CSB found that maintenance spending increased between 2003 and 2004, but most of the increases were for responding to serious accidents and complying with environmental requirements, not for preventive maintenance. Late in 2004, the Texas City refinery manager made a presentation to supervisors titled Safety Reality. reviewing fatalities at the plant over the past 30 years. One of the slides was entitled, "Texas City is not a safe place to work."
BP did its own safety culture survey that was done just prior to the accident. That survey indicated there was an exceptional degree of fear among employees of a major catastrophe.
Among the findings of the survey, the pressure for production, time pressure, and understaffing are the major causes of accidents at Texas City. Critical events, like failures or breakdowns, are generally not attended to. Production and budget compliance gets recognized and rewarded above anything else. Sociology professor Dr. Andrew Hopkins has written extensively on the causes of industrial disasters.
My feeling is that the solution to this problem of cost-cutting by senior people is to hold them responsible for the safety implications of those cost cuts, so that when they order a cost cut, they should personally be able to certify that these things will not have adverse safety consequences.
The Safety Culture Survey also pointed to the exceptionally high executive turnover at the refinery. 6 different business unit leaders, or BULs, in 7 years prior to the accident. The authors of the survey report concluded, "We have never seen an organization with such a history of leadership changes over such a short period of time."
Many managers are in and out within a space of 2 years, and what they are assessed on the basis of is the profit they make on an annual basis. Now, am I, as a manager, am I going to spend a large amount of money to deal with some remote risk that is very unlikely to generate a major accident during my year or two on my watch here?
The survey of Texas City employees also found concern about safety and equipment checks potentially left undone.
There was a check-the-box mentality, which indicated that personnel would go through the motions with various policies and procedures, but the work would not be conducted.
For example, the tower high-level alarm had been reported as not functioning several times in the 2 years prior to the accident. But maintenance work orders for this alarm were closed, although the repairs were never actually made.
Work orders could be closed out as completed, even though the work hadn't been performed. This is important because we found that on the day of the incident during the ISOM startup, there were a number of instruments and equipment that were not functioning properly.
On February 20th, 2005, a company safety manager wrote, "I truly believe we are on the verge of something bigger happening." Then, 3 weeks later, a BP business plan recognized a number of key safety risks, including that TCS, or Texas City site, kills someone in the next 12 to 18 months. 8 days later, those fears were realized.
Here were these warnings. These audits were sounding very clear warnings. So why weren't they attended to? I think my feeling is that Texas City was virtually paralyzed by the cost-cutting which had occurred at that site, and they were simply unable to respond to those warnings.
There needs to be somebody on the board of directors who can interpret those reports and be in position to drive change effectively.
The CSB's final report recommended that BP appoint an additional non-executive member of the board of directors with specific expertise in refinery operations and process safety.
Now let's spend a minute and think about, after viewing this video, what went wrong? What went right? What could have been done to prevent this disaster? Could a disaster like this happen at your own facility? Additional information to provide you with details can be found in your reference documents from the inspection fact sheet performed in 2009 at BP Texas City. Please take a look at this to provide you with additional information about events that have happened in the last couple of years at BP Texas City Refinery. In a speech by Jordan Barab, Deputy Assistant Secretary of OSHA, he posed the question of whether we've learned anything since BP Texas City. In summary, he stated that in the past 3 months, 58 workers have died in explosions, fires and collapses at refineries, coal mines, an oil drilling rig, and a natural gas-fired power plant construction site. And since the explosion in 2005 at BP Texas City, there have been over 20 serious incidents at refineries across the country. The status quo isn't working. There's much more to the PSM program. Now let's briefly review the national emphasis programs for refineries and chemical facilities and the severe violator enforcement program. The petroleum industry has had an NEP in existence since August of 2009 and continues today. The Chemical Facilities National Emphasis Program was issued July of 2010, was extended until September of 2010. At this point in time, there is no NEP for chemical facilities. During the OSHA inspection process, the standards that are typically cited include process safety management, lockout-tagout, HAZWOPER, hazard communication, confined space, the general duty clause, and hazardous locations. The most frequently cited PSM citations include operating procedures, process safety information pertaining to equipment, process hazard analysis specific criteria, mechanical integrity inspection and testing, process hazard analysis recommendation, and management of change implementation. OSHA's Severe Violator Enforcement Program concentrates resources on inspecting employers who have demonstrated indifference to the OSHA Act. The Severe Violator Enforcement Program specifically references the OSHA CPL 03-00-010 Petroleum Refinery Process Safety Management National Emphasis Program, which was issued August 18th of 2009. During this enforcement program, they have enhanced follow-up inspections, nationwide inspections of related workplaces and work sites, increased company awareness of OSHA enforcement, enhanced settlement provisions, and federal court enforcement under Section 11B of the OSHA Act. The bottom line here is that OSHA is serious about enforcement of process safety management. As mentioned earlier, in addition to process safety management, companies may also be required to comply with the EPA risk management plans. Remember, the risk management standard was supposed to be a mirror image of the PSM standard, but it didn't happen. Risk management plans protect the community, while PSM protects the workforce. The basic requirements of a risk management plan for EPA include an executive summary, the registration process, off-site consequence analysis, the 5-year accident history, emergency response plans, prevention program summary information, and certification. Most of this process is done online, and you can actually go and see what companies in your local area are covered by risk management plans. However, for process safety management, you will not know whether they're covered because they're not required to post this information on the internet from OSHA. One of the requirements of the risk management plan is to do an assessment to determine, in the event of a catastrophic release, where the release plume would travel to and who would be affected. The affected areas might include a local school, hospital, or possibly the fire department who you're hoping to respond to your event. OSHA's Process Safety Management Standard, in summary, is a comprehensive yet difficult standard to comply with. Although it was promulgated in 1991, catastrophes continue to occur today. Recognizing these facts, OSHA has developed 2 national emphasis programs to cover both refineries and chemical manufacturers. More emphasis is planned for all process safety management sites, and there's still much more work to be done. Risk management plans must also be considered for the EPA when you're assessing process safety management under OSHA at your own facility. Tools for additional process safety management assistance include a process safety management checklist, which can be found at www.oshainfo.gotech.edu, OSHA's website at www.osha.gov, and the Chemical Safety Board website, www.csb.gov. In order to provide additional assistance, check out our PSM checklist. This checklist covers 3 main elements that you will want to cover when reviewing your PSM program. This includes a records review, evaluation of the on-site conditions, and employee interviews. In order to gather the information needed to do a PSM audit, the following questions need to be asked for each of the PSM program elements: who, what, where, when, why, and how. For more information, check out www.psmtraining.com, www.oshainfo.gotech.edu, and www.pe.gottech.edu/safety. If you have questions or need additional information, please feel free to contact Michelle Dunham, Bob Hendry, and Art Wickman at the Georgia Tech OSHA Consultation Program in 21D. Funding for this training, Process Safety Management of Highly Hazardous and Explosive Chemicals, Simple Keys to Compliance, was provided by special funding from the Occupational Safety and Health Administration.